Hello, my dear students. Today I am here to teach you another very important topic, that is extraction of metals. और आज हम बहुत डिटेल में डिस्कस करने वाले हैं कि हाउ आयरन मेटल इज एक्सट्रैक्टेड from its ore industrially. So let us begin with the introduction of metals. You know, metals are the electropositive elements which are capable of losing their electrons to form their cations. And when we see more than 90% of the elements have got electropositive nature. So the most of the elements in the periodic table are called as metals, and they are having different tendency of reactivity. Means all the metals are not similar in their reactivity. Some metals are very active, some metals are moderately reacting, and some of the metals are found in native in the earth crust. Means they don't react and they are found free like noble gases. So we see most of the reactive metals are present in the compounds, and when we need them, we need to extract them from their ores. And the ores are the minerals which are obtained as it is they are mined from the earth crust. And how we can extract them? It depends on the position of the metal in the reactivity series. Now, generalizing the extraction methods in relation to the position of metals in the reactivity series, we see the lower the position of the metal in the reactivity series, the easier it is to extract. Let's talk about silver and gold. As you see, they occur native in the ground, means they are found in free state. But when we talk about potassium, sodium, calcium, magnesium and aluminum, they are very reactive comparatively as compared to other metals, and they are extracted by means of electrolysis. And when we see the middle moderately reactive metals, zinc, iron, tin and lead, they are extracted by means of reduction using carbon. And in today's lecture, we are going to talk about the extraction of iron in detail. We see the iron is extracted from its ore by using carbon. When we talk about its occurrence, iron is very reactive and is found in nature in the form of its oxides, carbonates and sulfates. Means iron is present in bind state in the form of chemical compounds, and the ores are hematite, magnetite and iron pyrite. And out of these ores, the main ore is hematite, which is iron 3 oxide. As you can see, this Roman 3 is written in the bracket is specifying the oxidation state of iron, and the iron 3 is always yellowish brown in color. So what do you relate by its color? Yes, the color is also depicting that it has iron plus 3 in it, and chemically hematite is iron oxide, Fe2O3 is the formula. And the ore also has some impurities in it, which is mainly silica or silicon dioxide. Now we see how we can extract iron from hematite. We need a specially designed constructed furnace, a longitudinal kiln, in which there are many outlets, such as in the bottom of the furnace we have an outlet to get molten iron, another outlet through which molten slag comes out. From the top, it has the position to drop the charge or the raw materials, and it is also provided with 2 outlets through which hot waste gases will be escaping. And two very important inlets are through which the hot air is blasting inside the furnace. So we begin with the raw materials. What are the raw materials required? We need iron ore, hematite, coke, which is purely carbon, and limestone, which is calcium carbonate. As you can see, the charge or the raw material are inserted or dropped from the top of the furnace, where the hot air is entering the furnace, which is heating up the raw material. And you can also observe that as we go down the furnace, the temperature is rising. So we see the reaction begins. The very first reaction which takes place in the blast furnace is when hot air reacts with coke. Chemically, carbon is oxidized with oxygen to give carbon dioxide. The second following reaction is when carbon dioxide reacts with coke. And in this step, carbon dioxide reacts with carbon to give carbon monoxide. Now this is the main reducing agent which is produced in the furnace by coke and hot air. Now we see the next reaction involves the reduction of iron ore. We see this iron ore is Fe2O3 and it has iron plus 3 in it. But iron is not free. So we use carbon monoxide to remove oxygen through it. So the loss of oxygen from the ore will be termed as reduction. So in this step, we can see that this is the main reaction which is extracting or releasing metallic iron, that the carbon monoxide is reacting with iron ore, that's hematite, to release iron and carbon dioxide. And you see this iron is released at more than its melting point. At the melting point of iron is 1385 degrees Celsius. You see, more than 1300 iron will be found in molten state or it will melt down. So this very dense iron sinks to the bottom of the furnace where it is tapped gradually. The last reaction also helps us to talk about the removal of other impurities. As you see, we drop limestone, calcium carbonate, which is thermally decomposed to give calcium oxide and carbon dioxide. And the calcium oxide, which is produced after decomposition of calcium carbonate, reacts with the silicon dioxide, which is found in the ore. And we don't need sand in our product iron, so we remove it by using calcium oxide to make a slag of calcium silicate. As the calcium silicate slag is lighter in density than molten iron, it is tapped off here. So we see the iron which leaves the furnace is in the molten form and is called as cast iron or pig iron. It is not 100% extracted pure iron, but it also has some impurities in it and it is purified further. So this is our product. Now we also talk about the waste gases. As you see, the gases are produced in the furnace. Those are carbon monoxide and carbon dioxide, and they escape through the outlets at the top of the furnace. So this is how the iron is extracted from its ore. So you watch the video and read the topic thoroughly from the book to learn it well, so that you will be capable of answering all the questions and all the MCQs from your past year papers or your chapter exercises. Thank you very much and wait for my next video. Till then, bye bye, take care, God bless you.